Good morning, everyone. I am Dr. U. Shakti, working as Assistant Professor in Department of Computational Intelligence, School of Computing, SRM Institute of Science and Technology, Katanglatur. Today, we will see the topic Strassens matrix multiplication. Here, the input is two matrices, A and B. A is multiplied with B, the result is stored in another matrix C. So find the product C is equal to A star B. A and B and C are two-dimensional square matrix. Here in this example, I am taking 2 cross 2 square matrix. So matrix A contains 2 rows and 2 columns. The column and row elements are represented using the row number and column number. A11, that is first row, first column. And A12, first row, second column. Like that, we can represent the matrix elements for A and B. So B11, B12, B21, B22 are the elements of B matrix. Now we are going to find the value of C matrix. C11, C12, C21, C22. So this is a problem statement. So A, B and C are 2 cross 2 matrices. A multiplied with B, the result is stored in another matrix C. This is the problem statement, and we will see how to implement matrix multiplication using brute force approach. What is brute force approach? The problem statement is implemented as such without any modification. That is the brute force approach. So normally how we are doing matrix multiplications, we are taking elements from row by row in first matrix, that is multiplied with every column in the second matrix. So here, take the matrix A, first row A11, multiplied with B11. That is the first element in the first column of B matrix. And take A12 in the matrix A, that is multiplied with second element in the first column of B matrix. A12 into B21. And next, the same row multiplied with the second column in B matrix. So A11 into B12 plus A12 into B22. Now, take the second row from the A matrix. So, multiply with every column in the B matrix. So, A21 into B1, 1 plus A22 into B21. And the last value is the same row, second column. A21 into B12 plus A22 into B22. So, this is a normal procedure, brute force approach for matrix multiplications. Here, basic operation is multiplication. Here, see in this example, how many multiplications for the first element? There are two multiplications. The first row, second element, two multiplications. And the second row, two multiplications. The second element, two multiplications. So totally there are 8 multiplications. And how many additions? Each element has one plus operation, there is addition operations. So there are 4 addition operations. So in this brute force approach, if n is 2 cross 2 matrix, n's cube, n power 3. So 2 into 2 into 2, 8 is number of multiplications. This is general formula for finding number of multiplications. If n is the size of the matrix, number of multiplication performed by algorithm is n cube, that is 8. In this scenario, if n equal to 2, there are 2 power 3, 8 multiplications, and number of addition is 4. And see the example, A is 1, 2, 3, 4, B matrix 4, 3, 2, 1. Now we are going to find the elements of C matrix. That is C is equal to A star B. That is the matrix multiplications. So take the first row from the matrix A, multiplied with every column in the second matrix. And take the second row from the matrix A and multiply with every column in the B matrix. So the result is 8, 5, 20, 30. Here see the exam multiplication. Number of multiplication is 8. Number of addition is 4. This is brute force approach. Normally, we are doing brute force approach. And the algorithm is, algorithm name is multiply. There are 3 matrices, A, B input matrix and C is output matrix. There are 3 loops. for I equal to 0 and for j equal to 0 and k equal to 0. So for I is taking I points a row in matrix A, j points column in B matrix, and K represents, we are taking the element from first matrix row and second matrix column. So K is the element index variable for taking the element one by one from the row and column. So here C of ij equal to C of ij plus A of ik into B of kj. So here for every iteration, there is one multiplication. So number of multiplication is 8. So there are 3 for loops. So number of iterations will be n into n into n. So n cube. So there are n cube iterations. Each iteration, there's one multiplication. That is A of ik into B of kj. So for every value of I, there is one multiplication. So this loop is the addition statement. C of ij equals C of ij plus A of ik into B of kj. This multiplication is executed for n cube times. So that is 8 multiplications. Algorithm performs, in this example, if n is 2, algorithm performs 8 multiplications. So time complexity of brute force approach is T of n is equal to n cube, that is equal to order of n power 3. So the time complexity of matrix multiplication using brute force approach is order of n power 3. There are 3 for loops. So this statement is executed for n cube times. So that is order of n cube. That is the time complexity of 2 cross 2 matrix, or the matrix with the size n using brute force approach is order of n cube. And we will see divide and conquer approach. How we can apply divide and conquer approach for matrix multiplication. So normally what is divide and conquer? Divide the problem into number of subproblems and solve the subproblem individually and combine the solution of subproblem to get the solution for original problem. Here in the case of matrix multiplication, the given matrix is divided into number of sub-matrices. And that is solved separately and the results are combined to get the result of the final matrix C. So here, if n is 2, then apply Strassens multiplication algorithm and find the result. If a matrix size is 2, there is no need of divide and conquer approach. If n is greater than 2, we can go for divide and conquer approach for matrix multiplication. Here, the important concept is the n. N is size of the matrix. So this is square matrix. Number of rows and number of columns should be equal, n cross n size. Here, what about the nature of n? N should be the power of 2. That is a constraint for divide and conquer approach. So like that is power of 2 means 2 power 0, 1. The single element matrix, and 2 power 1, 2 cross 2, 2 matrix, and 2 power 2, 4 cross 4 matrix, and 2 power 3, 8 cross 8, 2 power 4, 16 cross 16 matrix, and 32, 32, 64, like that it will go with the power of 2. So here n is power of 2. 2 power 0, 2 power 1, 2 power 2 is the size of the matrix. So this is the input constraint, and so A and B are the given square matrices with n cross n size. And output is C is equal to A star B. So size of the matrix C is should be same as the matrix A and B. That is n cross n. Here, what's the process? This is a divide and conquer approach. So the problem should be divided into number of submodules. So the given matrix A and B divided into 8 submatrices. So the matrix A divided into 4 parts, 4 sub-array, and the matrix B divided into 4 sub-arrays. So matrix A 4 submatrices and matrix B divided into 4 submatrices. So totally there are 8 submatrices in the initial iterations. So if n is the size of the matrices, next the submatrices size will be n by 2 and n by 2. So that is divided into 8 submatrices of size n by 2 into n by 2. Then the process is repeated recursively. This process is repeated recursively. Still we get the solution for the original matrix C. That is, we are finding the submatrix for C. Then substitute submatrix in C to get the final result of C. That is the process. And divide and conquer approach is faster than brute force approach. Here, that is, divide and conquer approach is suitable for large matrices, large size of matrices. But brute force approach is better for small size matrices. If the problem size is increased, this is more than 16 or 32, we can go for divide and conquer approach. If the problem or the matrix size is less, we can go for brute force approach. Here, this is a Strassens matrix multiplication formula. There are M7 formulas. That is formula M1 to M7. So, we have the input, all the element values are taken from matrix A and matrix B. So, A11 plus A12 plus into B11 plus B22. Like that, we are calculating the values of M from M1 to M7. So using these 7 M values, we can find the submatrix value for matrix C. That is, C matrix element is C11, C12, C21, C22, CT2. So apply these M7 values to find the value or to find the value of C matrix and substitute the value in the final matrix C, and that is the final result of C. So here A, B and C are 2 cross 2 square matrices. So the problem is to find C is equal to A star B. So the number of here, see the formula M1 to M7, how many multiplications? There are 7 multiplication. That is the difference between brute force approach and Strassens matrix multiplication. Here N is 2, number of multiplication in brute force is 8. Here in Strassens matrix multiplication, that number of multiplication, the basic operation multiplication is reduced to 7. That is, which is one lesser than brute force approach. In brute force, number of multiplication is 8. In Strassens, number of multiplication is 7. But in the case of addition and subtraction, that is increased. Here, addition is 11. But in the case of brute force, the addition is only 4. And number of subtraction is here 7. In brute force approach, there is no subtraction. So total number of addition and subtraction is 18. So the main advantage of Strassens multiplication is number of multiplication is reduced to 7 from 8, which is 1 lesser than brute force approach. And matrix multiplication comparison. So to find C is equal to A star B, Strassens matrix multiplication algorithm performs 7 multiplication, which is one lesser than brute force approach. Brute force approach 8 and Strassens multiplication 7. So divide and conquer approach based matrix multiplication using Strassens algorithm is efficient for large size of matrices. So this divide and conquer approach and using Strassens matrix multiplication is suitable for larger size of matrices. So brute force is better when n is small. See the table. So n is equal to 2 cross 2 square matrix. The brute force number of multiplication is 8, number of addition is 4, number of subtraction is 0. But in the case of Strassens multiplications, number of multiplication is reduced to 7. Which is 1 lesser than brute force approach. But the number of addition is increased from 4 to 7. Here in Strassens, number of subtraction is 7. But in the case of brute force, there is no subtraction. That is 0. This is the comparison of brute force approach and Strassens matrix multiplication. Here we are finding the time complexity based on only the multiplications. We are not taking addition and subtraction for finding time complexity. So matrix, there's a multiplication operation leads to more time complexity. So we are taking only the multiplication operations. We are omitting addition and subtraction for time complexity analysis. And see how we can apply divide and conquer approach for matrix multiplication. So here we are taking n equal to 4. 4 cross 4 matrices. So A, B and C are 4 cross 4 matrices. So we are finding C is equal to A star B. A is 4-dimensional matrix. B is 4-dimensional matrix. So the result is also C is also 4-dimensional matrix. So how we can divide the matrix A? So divide conquer approach, the given matrix A is divided into 4 sub matrices. That is taking first part, that is A11. See ends A12. That is first row last two elements, second row last two elements. That is A12. And come to the third row and fourth row. That is A21 and A22. So the given matrix A is divided into number of 4 sub matrices. And also B is also divided into 4 sub matrices with n by 2 size. Here n is 4 cross 4 and the sub matrices size is 4 by 2, that is 2 by 2. That is divided into 4 equal sub matrices. So size of sub matrix is 2 cross 2. Size of matrix A is 4 cross 4. So that is the divide steps. Now the divide step is over. Then we will see how to conquer, how to find out the multiplication value. So now take the C matrix. We are going to find the value of 4 submatrices. What are the 4 submatrices in C matrix? C11, C12, C21 and CT2. So now we are going to find the 4 submatrices value for C and substitute the value in the matrix, original matrix, we can find C value. Now our aim is to find the value of C11, C12, C21 and CT2. Now this is the algorithm for Strassens multiplication. So input is A, B and n is size of matrices. If n equal to 1, that is one dimension. We have only one element in A matrix, one element in B matrix, that is normal scalar multiplication. That is C11 equal to A11 into B11. And else if n equal to 2, 2 cross 2 matrices. 2 cross 2 matrices, just we can apply Strassens formula and we can find the value of C matrix. If n is greater than 2, that is starts from 4. So n is power of 2. 2 power 0, 2 power 1, 2 power 2. The next is 4 cross 4 matrices. If n is greater than 2, we can go for divide and conquer approach. So now it has 4 recursive call because A is divided into 4 submatrices, B is divided into 4 submatrices. So we have 8 submatrices. We have 8 recursive call. This is a recursive algorithm. The same function is called recursively. So the input is n, that is divided into 4 submatrices with n by 2 size. So after the division, A and B both divided into 8 submatrices of size n by 2. So then till we have a divide operation is performed till we have a 2 cross 2 matrices. So if we have 2 cross 2, we can apply the formula M1 to M7, we can find the value of C matrix. So this is a general algorithm for Strassens matrix multiplication using divide and conquer approach. We will see an example. Strassens matrix multiplication example, consider 2 matrices A and B with 2 cross 2 dimension. So here we are not applying divide and conquer approach because the size is only 2. If the 2 cross 2 matrix, no need of divide and conquer approach. Just to apply the formula M1 to M7 and apply these M1 to M7 values in C formula. That is C11, C12, C21, C22. Then find out the value and substitute the value in a matrix C. So we can get the product of A and B in C matrix. Here, there are 7 multiplications. From M1 to M7, there are 7 formula. Each formula has 1 multiplications. So there are 7 multiplications. So compared to brute force, that is number of multiplication is reduced to 7. That is, it is 1 lesser than brute force approach. That is Strassens matrix multiplication. This is for 2 dimensions. Next, if take 4 cross 4 matrix multiplication. So how 4 cross 4 matrix multiplication performed using brute force approach. So we know brute force approach. So we are taking first row that is multiplied with every column in the second matrix. So see the first row, there are 4 multiplications in each value. So here we have 2 power 4, that is n power 4 multiplications. So this is normal brute force approach. And we will go to divide and conquer approach using Strassens multiplication. So there are 3 matrices with size 4 cross 4, and divide the matrix A and B the size n into 8n by 2 size matrices. So we have 8 2 by 2 sub matrices. See A11, A12, A21, A22, B11, B12, B21, B22. So see and this is input matrix. We are finding the value of matrix C. So now we are going to find out the sub matrices of C. That is C11, C12, C21 and C22. So we are going to find 4 sub matrices value for C using divide and conquer approach. See here, the matrix A is divided into 4 sub-problems, sub-matrices. B is divided into 4 sub-matrices. So, how we can do? Apply the same formula, Strassens multiplications. M1 to M7. And apply this M value in C formula, find out the matrix. Here, this star represents this is a 2-dimensional matrix multiplications. Plus represents this is a matrix addition. Here, because the input A11 is not a normal scalar value. Here A11 is a that is here the diagram we have represented using capital A11, but it's a formula we have small A11. Both are same. So here A11 represents not a scalar value, is a 2-dimensional matrix. A, B, everything is a 2-dimensional matrix. Here plus represents 2-dimensional matrix addition. Star represents 2-dimensional matrix multiplication. Here this is a for 4 cross 4 matrix. Plus and star represents matrix multiplication and 2 cross 2 matrix addition, not a scalar value. So how to find the value from M1 to M7? So apply the formula. What is first? We will see what is M1, A11 plus A1, A22. So A11 is 1 to 1, 1. That is applied here 1 to 1, 1. Then the next value plus, then next 2 value is a multiplication. So add 2 matrix. It's a matrix addition. See the result, and that is multiplied with second part. So this is a matrix, 2-dimensional matrix addition. So here if n is 4 cross 4 matrix, if we apply divide and conquer approach, the input is 2 cross 2 matrix. So plus represents matrix addition, star represents 2-dimensional matrix multiplication. So like that, we have to find out the value from M1 to M7. So all M1 to M7 are, the results are, see the last value, say 2 cross 2 matrix. That is the result of M1 to M7, so 2 cross 2 matrices. And apply these M1 to M7 value in C formula. In C formula to find the sub matrices of the matrix, output matrix C. So C11 is, we have the formula in this slide. C11, that is C11 equal to M1 plus M2. Here all M values are 2 cross 2 matrices. So after finding M1 to M7, substitute this M value, that is 2 cross 2 matrices, in C formula. Here we go matrix addition and matrix subtraction. So find out the C112, C22. That is find out the sub matrices of the output matrix C. That is the formula, 4 values. So matrix addition, matrix subtractions. So substitute these values C11, C12, C21 and C22 in the C matrix. So this is the final result of C matrices. So this is the example for divide and conquer approach for matrix multiplications using Strassens formula. So this is applicable when n equal to 4. Starts from 4 greater than 2. And this is a C program for Strassens matrix multiplication. That is, this is a 2 cross 2 multiplication. Just we are defining 3 matrices A, B, and C. So we have the variable M1 to M7. So we are finding the value M1 to M7. So first for loop, get the value for matrix A. Second for loop, for I equal to 0, J is equal to 0. Let's get the value for matrix B, and just we are printing the input value in the matrix format. So the first matrix is print the value of first matrix, second matrix print the value of second matrix. Just in this slide, the first half is the code for getting input for matrix A and B. The second part, just we are printing the input matrix A and B in the matrix form. Here we are finding Strassens formula M1 to M7 value. That is input is A matrix and B matrix. This is a two-dimensional, input is two-dimensional matrix. So this is scalar value. So after finding M1 to M7, we have to find the value for matrix C. This 4 formula for C. C0001, 1011 using M formula. So this is the value of C matrix. Just to print the matrix of output of C matrix. So get 4 elements. See the output. First get the value for matrix A. Get the values for matrix B. Just next one, print the matrix A and B in a matrix format. So after multiplication using Strassens algorithm, we are getting the results. So for, like that, we have to write the code for 4 cross 4 matrix multiplication. Next, here, analysis of algorithm. So how to find the time complexity? The time complexity of divide and conquer approach for n cross n matrix multiplications using Strassens formula. So it is a recursive algorithm. The same function is called recursively, and it works based on divide and conquer approach. In each iterations, there are 8 recursive calls because the given matrix A and B is divided into 8 submatrices. So there is a 8 recursive call, and the same function is called 8 times. The basic operation is multiplication. During each iterations, 2 cross 2 matrix multiplication performs 7 multiplications. So the recurrence equation T of n can be defined as T of n is time complexity on input size n. So 7 into T of n by 2. Each iterations, there are 7 multiplications. Each iterations, there are 7 multiplications. That is the advantage of Strassens multiplication. For 2 cross 2 matrix multiplications, Strassens algorithm performs only 7 multiplications. So first time, if n is input, 7 multiplication and the size is reduced by half. That is input n divided by 2, T of n by 2. So this is a recurrence equation. When we solve this recurrence equation by using Master's theorem, so we are getting the answer T of n is equal to order of n power 2.808. So to n power 2.808 is the running time of 2 cross 2 matrix using Strassens algorithm. So which is lesser than order of n cube. So how to find the time complexity? So if n is equal to 1, so we write the initial conditions. If n is 1, that is one dimensional array. We have only one element. in A matrix, one element in B matrix. So if we multiply these two, algorithm performs only one multiplications. That is T of 1 equal to 1. That is T of 1 is N equal to 1. For if the dimension is 1, T of 1, number of multiplication is 1. That's the initial conditions. And we know the relations N equal to 2 power K. That is the basic concept of divide and conquer approach. For every iterations, input size is reduced by 2 or half. So if you solve these equations, we can find number of iterations k equal to n log n. K equal to log n. So T of n is equal to 7 T of n by 2 is the first equation. And T of n by 2 equal to 7 into T of n by 4 is the second equation. Again, if n is input, n by 2. Again, if n by 2 is input, 7 into T of n by 4. So the next recursive call. And the third recursive call, n by 4 is input. So 7 into T of n by 8. So this process is repeated till we have a single element. So how to solve this equation? By substitution method. So this is substitution method example. Substitute equation 3 in 2. So we are getting T of n by 2 equal to 7 square T of n by 8. So substitute T of n by 2 in first equation to find T of n. So T of n is 7 power 3 into T of n by 8. So 8 we can write with the power of 2. So 2 power 3. So in general, this is for third iteration. Next, like that, 7 power 4, T of n by T power 4, 2 power 4. So like that, it will go till we have a single element T of 1. So in general, we can write, instead of 3, we can write K. So 7 power K, T of n by 2 power K. So we know the relation n by 2 power K equal to 1. So substitute T of n by 2 power K equal to 1. That is, we are getting T of 1. So initial condition T of 1, we know the value. See the first line, T of 1 is 1. If n equal to 1, algorithm performs only one multiplications. So T of 1 is equal to 1. So substitute the value in this equation. We are getting 7 power log n. Because K value is log n. 7 power log n. And into T of 1 value is 1 into 1. So we are getting 7 power log n. So how we can write 7 power log n? See the code. A power log b is, we can change the power and the log value. So B will come to the base and A will go to the log value. So B power log A, both are same. A power log B is equal to P power log A, both values are same. So we are converting 7 power log n as n power log 7. N power log 7, that is the value. Log 7 base 2 value is 2.808. So T of n is equal to n power log 7. So log 7 value base 2 is 2.808. So order of n power 2.808. This is the time complexity of divide and conquer approach for matrix multiplications using Strassens formula, which is lesser than brute force approach order of n cube. This is very important time complexity using brute force order of n power 3, using divide and conquer approach order of n power 2.808. 2.8 is lesser than order of n cube. So divide and conquer approach gives less time complexity compared to brute force approach. And in the second case, time complexity analysis, we can write recurrence equation T of n is equal to B for n less than or equal to 2 and 7 into T of n by 2 plus Cn square. So we know 7 into T of n by 2. For each iteration, number of multiplication is 7. And what is C plus Cn square? This is the time taken for matrix addition. So we are adding algorithm M1 to M7. It performs matrix additions. In this analysis, we are taking the time complexity for matrix addition. There is addition operation also. So if we give 2 cross 2 matrix addition, for every value in matrix A is added with every value in matrix B. So the time complexity is n square. That is, so first one is time complexity for multiplication 7 into n power by 2 plus Cn square is time complexity for matrix addition. So each iteration's size is reduced by 2. N T of n by 2. Again T of n by 2. 7 into T of n by 4. That will go like this. During each recursive call, Strassens algorithm performs 7 multiplications. Here, that is 7 into T of n by 2. So C of n square is the time complexity of matrix addition. If the input is n cross n for matrix addition, that is n cross n plus n cross n, to matrix addition, then the time complexity of the addition algorithm is n square. Every element in one matrix added with all the elements in the second matrix. So Cn square is the time taken for matrix addition in matrix multiplication algorithm. So how to find? That is time complexity is works based on 8. So which is lesser than order of n cube. The recurrence equation T of n can be solved using Morse's theorem. So which is lesser than order of n power 3. So how to solve this recurrence equations? So T of n equal to 7 into T of n by 2 plus Cn square. So 7 into T of n by 2 is each iterations there are 7 multiplications. Plus Cn square is for each iterations n square is number of additions for 2 matrix. C means for C number of matrix additions. So that is first equation. Again, recurrence equation, we are finding T of n by 2 is the input for second iteration. If n by 2 is input, so we are getting 7 into T of n by 4 plus instead of n substitute n by 2. So n square is the first one. Here second one n by 2 whole square. And T of n by 4 is 7 into T of n by 8 plus C into n by 4. So instead of n, substitute n by 2. Instead of n by 2, substitute n by 4. That is divide and conquer approach. First iteration n is the input. Second iteration n by 2 is the input. Third iteration n by 8 is the input. So substitute equation 3 in 2. So substitute the value so substitute after finding T of n by 2, substitute the value of T of n by 2 in the equation 1. So finally we are getting T of n is equal to 7 power 3 T of n by 2 power 3 plus Cn square into some constant value. So the constant value is so that is for the in general we can substitute k. So like that it will go 7 power 3, 7 power 4, 7 power 5. So in general we can substitute k. So 7 power k T of n by 2 power k plus Cn square into 7 by 4 k. And we know the relations n by 2 power k equal to 1. Substitute k equal to log n. So 7 power log n plus Cn square 7 log n. So we can write 7 by 4 log n as 7 log n divided by 4 log n. And so 4 log n can be written as 2 power 2 log n. So 2 power 2 log n value is n square. So here n square getting cancelled. So the final result is 7 power log 2n plus c into 7 log n. So here 7 power log n we can write as the power will go to the log value will come to the base value. So n power log 7 base 2 plus c into log 7 log n. So n power value is greater than log n. So the log n value is lesser. So we can omit that value. And so n power log 7 value is 2.808. So that is order of n power 2.08. 8 is the time complexity for n cross n matrix multiplication using divide and conquer approach. So which is lesser than brute force approach. Here in this concept, we have two types of analysis. The first type of analysis, we are taking only multiplication as a basic operations. The second analysis, we are taking multiplications. For each iterations, there are 7 multiplications, 7 into T of n by 2 plus n square. The time complexity for matrix addition. So anyhow, the matrix addition, which is lesser than the matrix multiplications, so that component will be omitted. Finally, we are getting the same answer. That is order of n power 2.808. So how we can compare this algorithm? So n cross n square matrix multiplication. So the brute force approach, time complexity is order of n power 3. Divide and conquer approach using Strassens multiplication algorithm is order of n power 2.808. So 2.808 value is less than n cube. So divide and conquer approach is better than brute force approach for n cross n matrix multiplication. Thank you.